So does everybody understand the concept, like that we just talked about, really about the difference here? Like, what really is the difference between writing a domain like this and writing a domain? All right, so this is, like, I'm not going to get charged per hour. This is only 1 hour, 2 hour, 3 hour. This is, I can turn that scooter in anytime I want, right? Now, in real life, there's functions for everything, right? We could have a function for a toaster, right? A function, what I really want you to think about a function is it's a machine. Think of a function as a machine, okay? Because basically, how does a function work? If this is my function, you have inputs, and you have what? You have outputs, right? Great. We have a fancy name for the inputs. What's the inputs called? Domain. We have a fancy name for the outputs. We call it the range. Okay? Let's toaster. What's the input for a toaster? Bread. Cold bread. Cold bagels, right? What's the output? Nice, hot, warm toast, right? Toasted bagels, whatever. Do we have to, for some functions, restrict the domain? Meaning you can't put anything in there. Do you have to restrict the domain for a toaster? The answer is absolutely yes. Can you put Jell-O in a toaster? Can you put water in a toaster? You can't put anything in a toaster, right? Like, bad things are going to happen. You have to sometimes restrict this domain to a smaller set. Does that make sense? Like, most of the time, why do we restrict domains? What's going to happen if you don't restrict the domain for a toaster? Messes, bad things. You're going to break the toaster, right? Sometimes you're going to have bad things happen, errors in math, right? Things that are just not allowed to be able to be done, right? Let's just take a real simple one. Let's say f of x is equal to 10 divided by x. Can you divide 10 by any number you want? No. What do you mean no? What number or numbers are you never ever allowed to divide by? What causes errors? What causes problems? What's f of 0? What is 10 divided by 0? Are you allowed to divide by 0? No, that's error. That's bad things. Nothing happens. There is no answer to this. This is error, no solution. Okay? So you're not allowed to have that. So what we have to do for certain functions is we have to say the domain can't equal 0. Okay? Basically, is any other number okay? Can you put a 5 in there? Sure. Can you put a negative 5 in there? Sure. It's not going to cause any problems, right? Sometimes certain things are going to cause problems, right? And other times, it's not that they're going to cause problems. It's just we don't really care because it's not a reasonable request, okay? Let's take the example from the homework, okay? We're going to rent the scooters, or I'm going to rent a jet ski. I'm going out with my family. We're renting jet skis, right? I walk in, and I say, I want to rent my jet ski, and they say the cost is it's $45 to get in and $5 per hour, right? That was the problem from the homework. Great. Do I have an unlimited, in all reality, do I have an unlimited, let's say money's no object here. Do I have an unlimited domain? The answer is no. Am I going to rent that jet ski for 5,827 hours? No. I don't have that much time, right? Like, what is a reasonable domain here? Is 0 a reasonable number? No, 0 is not a reasonable number because, yeah, I want to go. I want to get on the jet ski. I want to go have some fun. Like, 0 to me is out of the domain. I'm not even going to worry about that in my domain because I don't care about that number in this particular instance, right? So what's the smallest number? Let's assume, for the sake of this discussion, let's assume it's this scenario. Meaning, they're only going to charge me 1 hour or 2 hour or 3 hour. If I turn that jet ski in 1 hour and 5 minutes, how much are they going to charge me for? 2 hours, right? Always round up, okay? So we're assuming this domain. You tell me, money's no object. I have all the money I want, unlimited credit card, right? What's a reasonable domain? We said 1 is the smallest, right? 2? 3? Tell me when to stop. 3 is good. You say 4? 4 hours on a jet ski? Is that good? Okay. 5? You tell me, what's a reasonable number to stop? Huh? 6 or 7? Why? Why are you stopping after 6 or 7? You're getting tired. I'm hungry. I've been on this thing all day. I don't care anymore, right? There's only so much stuff to do on a jet ski. Like, it's just not that much fun after so many times. So we're not going to worry about an unlimited amount because for certain instances, it's just not a reasonable number that we care to calculate, right? It's not that we couldn't. It's just it's not a reasonable request. Does that kind of make sense? Now, if this is the case, so let's say, for the sake of this, I don't even want to go that high because I don't know about you, but when I'm on vacation, I like to go do a lot of stuff, right? Like for me, personally, I would say 3 is about my limit. I probably aren't going to go any longer than that. Like, that's a whole afternoon to me. By the time you take time to drive down to the marina, check in, do all that, that's a good half hour, right? And then, you spend your time on the water. Well, I want to go get changed, and then we're going to have dinner, right? Like 3 hours, that's a long time. That's about my limit. You could argue 4 hours or 5 hours, I get it. But it depends on what else you're doing and all that kind of stuff. But for me personally, if I was on vacation, that's about it. Which also then means my range is very limited. So what's my range? I only have to worry about bringing how much money. I need at least how much? What's the smallest amount I could have to charge? 50. Well, I better bring a $50 bill. I better bring another 5. And I better bring another 5, right? I need at least this much money. Now, maybe you want some, you want a Gatorade or something while you're on the water. You bring a little extra money for some snacks, but that's about it. Otherwise, I'm going to leave all my money back at the hotel or campground or wherever you're staying. I'm only going to bring this much money. It also means it's going to affect this situation graphically. Because now, I have a 1 here. Oops. Come on, pen. If I plot these points, a 2 and a 3, we'll say this is 50, 55, and 60. Is this going to be a continual line, or is this going to be a discrete graph where I would only plot this point, and this point? Is this going to be a continuous line or a discrete? This is going to be discrete. Okay, so sometimes when we're actually drawing the graphs, we say, no, I know this is a line. Like if I were to take this and get a graphing calculator or whatever, and just I plot that line, right? Come on. Turn on. I can plot that graph. I can say, all right, that's the same thing as y equals 45 plus 5x. I can hit graph. I won't be able to see it, much of it, because it's, I'm only by 10 by 10. I could fix my window so I'm really only looking from like 0 to 10. I need to start at least, we'll start the graph at 45 and end it at like 75. I could draw this graph. Is this graph plotting all the same points? But why in this case am I not drawing a line? Why am I not connecting the dots? Why am I only going to plot those 3 points? There's no halves, there's no decimals, right? I'm not worried about those things. It's not that I couldn't, it's just I don't care in this case. Does that kind of make sense? So sometimes we're forced to restrict domains because sometimes bad things happen, right? You're not allowed to put oranges in a toaster. Like that's a bad idea. It really is. You should never try that. And please, I don't want any phone calls tonight, from parents saying, my kid put an orange in our toaster and she said her math teacher told. No, I did not. I have proof. I did not tell you to put an orange in your toaster. Bad things are going to happen. Sometimes we have to restrict domains. Sometimes we restrict domains just because the other information is really just irrelevant to us. We just don't care in certain instances. Does that make sense? Everybody take a look at page 250. Well, let's just go right to the homework. 256. Okay? So if you look at number 1 on page 256, they give us an equation of 3x minus y is equal to 1, right? And they also gave us a domain. The domain, are those all your x's or are those all your y's? Those are your x's. So what are the x numbers they give you for number 1? They say plug in a -3, -1, 0, and a 4. Okay? Now, basically what we have to do is plug each one of those in for x and solve for y. Now, I, for one, there's 2 different ways you can do this. You can plug it in as is, or I would manipulate this before I plug it in. Here's the difference. You can say 3 times -3 minus y equals 1. What's 3 times -3? -9. Minus y is equal to 1. How do you get rid of this -9? Add the 9, so you get -y is equal to 10. If -y equals 10, then positive y equals -10. And then you have to do the same thing for the next problem. And you got to say 3 times -3 minus y equals 1. Oops, 3 times negative what? 1, sorry. Minus y equals 1. And you get -3 minus y equals 1. Add the 3. So if y equals 4, then y equals -4. Does that make sense? I would not do it this way because that's a lot of work for each individual problem, right? For me, what I personally would have done first, instead of doing that for every problem, I would have taken the 3 seconds it takes to say, you know what, I don't like 3x minus y equals 1. I want to get that to the point where it just says y equals. I want to move that 3x to the other side. So instead of positive 3x over here, it's negative y is equal to negative 3x plus 1. Remember doing that? And then if this is a negative y, how do you get rid of a negative? You multiply by a negative. That turns this to a positive, which turns this into a positive. And it turns that positive 1 into a negative 1. Now, try plugging them in. What's 3 times negative 3? Negative 9. Negative 9 minus 1? Negative 10. 3 times negative 1 is negative 3. Negative 3 minus 1? Negative 4. 0 times 3 is 0. 0 minus 1 is negative 1. 3 times 4 is 12. 12 minus 1. What's the benefit of doing this? Why? Because now you don't have to solve each one individually, right? The benefit of taking the little bit of time to solve for y first saves you in the end, because then you can just rapid fire. Does that make sense? This is how I personally would have done that. But the question they want you to do is they want you to graph this. This is a line. Do you guys remember how to graph lines like this? What's my y-intercept? Let's do this. It's y equals 3x minus 1. Well, do you guys remember the y equals mx plus b? What's my y-intercept? Negative 1. So it's going to go through negative 1. And what's my slope? It's going to go up 1, 2, 3, over 1. Up 1, 2, 3, over 1. This is a line. Now, should we graph the line in this case and connect all these dots? Or am I only plugging in these 4 points? I'm only plugging in those 4 points. So I don't actually want to draw this. What I actually want to draw instead is I only want to plot the points negative 3. I'm going to make this a little bit bigger. Negative 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, negative 4. 0, negative 1. 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 be right about there. Now, if I were to draw that line, would it really be the same line? Now, why are we restricting the domain? I don't know. It doesn't tell. This isn't like a story type problem where they tell us that these are the only 4 points that are reasonable that we care about, but that's all they want us to do. So should I connect the dots in this case? The answer is no, absolutely not. You'd actually be incorrect and wrong if you did connect the dots. What we're doing is we're saying, plot this line or plot this graph, come on, plot this, which is the same thing as this, but only do it for these inputs, because for some reason those are the only inputs we care about. Does that make sense? Okay. Let's look at number 5 though. What's number 5 say? Equals 6x plus 4. But what do they not give us? What's my domain? What's my domain for this problem? Does it say? My domain is all real numbers. Everything is in play here. Now, what points can we plot to get an idea of what this looks like? Anything we want. You remember doing this a few chapters ago? Like, what points are easy ones to plot? Yeah, we did like -2, -1, 0, 1, 2, right? I think those are the 5 we tend to go with. What's 0? Plug in a 0. What's 0 times 6? 0 plus 4? 4. Plug in a 1. What's 6 times 1? 6 plus 4? 10. Plug in a -1. 6 times -1, -6. -6 plus 4? -2. Great. This is just going to be a line. Connect the dots. Should I connect the dots in this case? 1, 2, 3, 4. So there's my 0, 4. 110 is going to be way up here somewhere. -1, -2 down here. In this case, should I connect the dots? Yes. Because they're basically saying any point on there is good. They're all good. Sometimes we don't restrict the domain. Sometimes we do. Does that make sense? So for numbers 1 through 4, what kind of graph should we be plotting? Discrete or continuous? Those are all going to be discrete. Just plot whatever points they tell you to plot. And then for 5 through 10, you plot a few points, get an idea what it looks like, and then connect the dots. That's a continuous. By the way, when you do a question like number 8, absolute value. If I plug in any points, let's plug in a -2. What's the absolute value of -2? 2. 2 minus 4? -2. Plug in a -1. Absolute value of -1 is 1. 1 minus 4? -3. 0 would be 0 minus 4. 1 would be 1 minus 4. Does anybody remember what the graph of this is going to look like? So we got -2, -2, -1, -3, 0, -4, 1, -3, 2, -2. All absolute value graphs end up looking like a V shape, right? Now, if it said restrict the domain, I would leave that as discrete. Just plot those 5 points. If it said there's no restriction, it's all real numbers basically, what's the only thing I should do to this graph? Connect the dots and draw the lines, right? Easy? What do all x squared graphs look like number 4 or number 9? Anybody remember what x squared graphs look like? That's your U shape. It's a parabola. So you should end up with some sort of U shape. Are we good with these? Do these make sense? Okay. Let me give you a weird homework assignment. Ready? Homework is page, when does it start? 256? I want you to go all the way to 51. All the way to 51. Count by threes. What's 60 divided by 3? 20. Is this even 20 questions? No, it's like maybe 15 questions. So I don't think this will take you all that long. Okay. When do you draw discrete? if it restricts the domain. It says domain is these 5 points, only plot those 5 points and be done. If it doesn't, like number 5, then you draw the whole thing, okay?